Hello everyone, welcome to my channel EC on Tips. I'm Samiksha Shrivastava. In today's lecture, I will be teaching MOSFET operation. So what is a MOSFET? MOSFET is a metal oxide semiconductor field effect transistor, and it is a three-terminal device, and it consists of a source, channel, drain and a substrate. And it is also called as body. And here this is oxide, which is of SiO2, and this is a metal contact and metal contact. And this channel, as in my previous video I have told you that how inversion layer is formed. So inversion layer is only formed when this condition is true, that is VGS should be greater than the threshold voltage. When the gate terminal voltage is greater than the threshold voltage, then only the channel will be formed, and this channel is the inversion layer. Is it clear? And then MOSFET consists of a MOS transistor with two PN junction. Okay, it consists of a two PN junction, this one and this one. Okay, so both PN junction are initially reverse bias. As we have already discussed, this will behave as a reverse bias. Okay, and now the MOSFET is, it is operated in basically three regions, that is cutoff region, linear region and saturation region. So in these three regions MOSFET is operated. Okay, so first we come to the cutoff region. What happens in cutoff region is that here VGS is less than the threshold voltage. That is, if VGS is less than threshold voltage, then what you will observe, this is the basic condition for the channel formation. So here there will be no channel formation, and if channel is not formed, then there will be no conduction of current. Is it clear? So I have made the half diagram of this MOSFET. You can draw the full diagram in your exams. Okay, so first problem in cutoff region is that VGS is less than threshold voltage, hence no channel will be formed. And the second problem is, that is, if we increase this VGS value greater than the threshold voltage, then definitely channel will be formed, that is inversion layer will be formed. But the problem is here is that here the source voltage is also grounded and drain voltage is also grounded. That is, here VD is also 0 and VS is also 0. What does it mean? That they both are at same voltage. If there is no voltage difference, then there will be no conduction of current. Okay, so here also I have written in the sentences, that is, now if we increase this VGS value, that is VGS greater than threshold, then this inversion layer is formed. Okay, this inversion layer is formed, that is the channel is formed. Now both source, that is both source and drain are grounded, so no voltage difference and no such conduction of current. It is clear? Then the next we come to the next region, that is the linear region. What is linear region? Linear region is also called as triode region. It is a region when the VGS is greater than the threshold voltage. If this VGS is greater than the threshold voltage, then definitely channel will be formed. So as VGS is greater than threshold, formation of channel will take place, but the thickness of the channel near the drain is less than the thickness of the channel near the source, because the voltage of drain is higher than the voltage of the source. Now let us understand these lines. As it says that as we can see that this will be the inversion layer, and you will observe that here inversion layer, here the channel will be in less quantity, or there will be in the less channel will be formed, and here will be the more concentration of channel, that is more concentration of negative ions. What is inversion layer? Inversion layer is full of negative ions. So here you will observe more negative ion, and here you will observe no less concentration of negative ion. Why is it so? Because we have applied this voltage at the drain terminal. Okay, as soon as we apply this drain voltage across this drain terminal, what will happen? This current ID will start to flow. Okay, this ID current will flow through this region and it will move towards the source terminal. Okay, so this ID current will flow to the channel. So ID current can flow easily, and the electrons will move from source to drain. That is, ID current will move from drain to source, whereas this electron will move from source to drain. Is it clear to you all? Now in this channel region will act as a voltage control resistor. Okay, so electron velocity in this channel is much lower than the drift velocity. What you will observe that this is the drift velocity, that is ID current is a drift velocity current. Okay, drift velocity, whereas this electron velocity is, for example, it is VE. Okay, and this is velocity of this current is ID. Okay, VID, you can observe, you can consider it. So what you will observe here, this velocity in the channel will be lower, this will be lower and this will be higher. Why is it so? Because there is no interruption of the channel, or any interruption will be, you will observe here. Okay, this ID current can easily flow from drain to source because there is no problem in the channel. The current can easily flow from here. So here will be electron density is constant. Here it will no interruption in the electron density. So electron density in the channel is much lower than the drift velocity because the channel is already present. Here the channel is already present, so no need of the increasing this velocity. Okay, now the next thing we have to study in this linear region only, that threshold of the linear region. What happened in threshold of the linear region? This VD, that is the drain voltage, is equal to VD sat, that is VD saturation. It is a condition in the linear region when this VD is equal to the VD sat. Okay, so what you will observe here is that as we increase this VD value, this region, that is previously the inversion layer is present over here. Okay, but now this region will keep on decreasing. Why it will keep on decreasing? By increasing this VD value. As this concentration increases, this layer become much thinner and thinner. So this a condition will come when this layer will be only touching at a point. Okay, this layer is only touching at a point, so this point is called as pinch off point. Is it clear? So as we increase this VD value furthermore, if we increase this value, keep on increasing this value, then pinch off point will be contracted and it will move towards this region. Okay, so this pinch off point, you will observe that it will move towards this source direction. Okay, now the third region we will be studying is the saturation region. What happens in the saturation region is, in saturation region you will observe that this pinch off point will move towards the source terminal. Okay, previously it was here, and if we keep on increasing this value greater than VD sat, if we keep on increasing greater than VD sat, then what you will observe that this pinch off point will move towards the source terminal and this vacant region will be created. That is, here there will be no concentration of the accepting ions, okay, or the negative ions. Hence this region will be empty and this region will be called as a pinch off region, okay, where there is no inversion layer. And here you will observe only this area will be having the inversion layer, and this area will be only attached at a point, and this point is called as a pinch off point. Okay, now the electron velocity in the channel is higher. Now electron are moving from here, and whereas this this current, ID current, is moving from here. Okay, so as you can see there is no channel, there is no channel present, so there will be no medium or a no channel for the current, ID current, to flow from drain to source. Okay, so there will be no flow of current, and here the velocity of this current has to be increased. Okay, so the here what you will observe that electron velocity is not getting any interruption, so it will move with a higher velocity, whereas this is getting interruption, okay, due to this vacancy, or you can say there is a no channel or a no medium for it to travel, hence there will be, this velocity will be lesser, it will move with a less velocity. So electron velocity in the channel is higher than the drift velocity because of this pinch off region. Because of this pinch off region, there will be, drift velocity will be lower than the electron velocity. Okay. Now the voltage drop across this pinch off region is equal to the VDS minus VD sat. So this is the voltage, total overall voltage drop across this pinch off region. Clear? And drain current will become constant. Why it will become constant? After a certain value, there will be, it will move, this source will, this point, pinch off point will move towards the source terminal, and there will be no medium for the current to flow through it, and hence there will be constant current you will observe in this. Okay, so these are the three regions of in which the MOSFET will be operated. So if you have any queries related to this, please comment down, and in my next video I will be teaching MOSFET current voltage characteristic. Thank you.